In our previous video, we did some SQL to combine a data set on tree species and a data set that looked at specific trees within New York. We did an inner join, we merged the two together, and we did this all in Biq Query in Google Cloud. Once you do that, so if your data is in Google Cloud or Amazon Web Service or Microsoft Azure, then you use SQL and joins to merge databases together. And then if you are going to do your analysis outside of the cloud computing, so maybe you're going to do it in Python, although technically we're going to do it in Google Collab, so we're still doing cloud computing. But if you are exporting it out of these big systems, then we need a way to pull it out. So here we have our query, and what we have here is our data set. So when it comes to our data set, there are two ways to pull it out. And my face is covering both options. So let's just see if we can't move me here. I'll move myself up there. Okay. So what you see down here is that you can do explore data or save results. So option number one is to save your document, and you can save it as a CSV file to your Google Drive, for example. And in the future, what we're going to be doing is we're going to be pulling Excel and CSV files from Google Drive to do analysis. So that is one option, is to save it to your Google Drive. Option number two is to do this explore data, explore with Python Notebook. And that actually opens up a Python notebook where you can run the query again. It's calling into the cloud, and then it will output the table. So we can do either one. So we can explore with Python notebook. And what it gives you here is it gives you a job number so that if you run it, it is going to just give you the SQL code that you had put into Google Cloud. So you can run it, you can get your SQL command that you had before. Now, when you're doing this, it's asking you to connect to your Google Drive. So we'll hit allow. It's not going to cost you any money. You're simply just saying that this Python notebook is my Python notebook. And so it's going to go into my Google Drive. And so I'm connecting Google Cloud and my Google Drive, but no money attached. You can still run it. All right. I don't know why it bugged out, but let's try that again. Allow, pick a Google Drive. Yes. Yeah, fine. All right. So we've set up the system. So what this does then is it allows you to see, here's that SQL code that you had just written. It also then allows you to run this, and it's created a table for you called results. And so you can see here, this is the compiled table. It has the health status, the borough name, the tree ID, but it also has the species information where we've combined the two together. So you are now in Python with a table called results, and that means you can do things to the table called results. You can do commands like describe the results, and this isn't super helpful for this particular data set because describe finds the average, the standard deviation, the min, and then the low is 25%, 75%, the min, the max. If your data like this is mostly strings of text, it can't do anything with it. And so this describe function is not particularly helpful. But you can see how it's taken the database we've created and ported it over to Python. If instead you decide you want to save your results as a CSV file, then what that's going to do is it's going to take a moment. It's going to dump it into your Google Drive. What you will need to do is you will need to rename it, and you'll need to move it. So it says it's exported, go to Drive. See how it creates a CSV file with some crazy names? So what I would want to do then is I can open it in Google Sheets if you want. but I simply just need to rename it and I need to relocate it. Okay. So if I go back here, I want to rename it to whatever this is, and this is my trees data, right? Okay. And then I'm going to want to move it somewhere. So I want to put it in a folder. So maybe I put it into where I'm working through this material, and that's because I want to later call it. So you need to know where it's at. So you need to know what folders it's in if you're going to go that route. Okay. So either one is good. We can call it and we can then do things with it. So why don't we give this a try? Let's try to do a query here where rather than a join, we also might just want to pull a data set. So if we're doing analysis from our big data set that we have stored in the cloud, we might want to just pull some information to do some data visualizations, build a dashboard, and so on. So let's suppose that we want to use data from our New York 311 data set. The table is called 311 service requests, and we want to figure out where the poison ivy complaints are coming from. Where in New York are people getting poison ivy? So we want to pull a unique key, so some kind of identifier of each event. Maybe we want to know which borough they're in, Staten Island, Queens, Bronx. A zip code, because we might want to later put this onto a map and we could color code it by zip code. Or maybe we want to highlight the exact location, so we want longitude and latitude. We're going to pull it from the New York 311. Notice that there is no join here, so it's only one table that we're pulling from. And here we are pulling a subset of the table. So we have select, from, and where. And we actually, if I look at this here, we don't want distinct. Let's change that. Distinct would be one each. We want all the data that's relevant here, so let's remove that distinct. Select unique key, borough, incident, zip, longitude, latitude from the 311 table where the complaint type is poison ivy. And of course, limit to 1,000. So let's go into BigQuery and let's find the 311. I'm just going to close all this stuff up. And I'm going to put my face back down, close that up, move myself back down here. There we go. Okay, so what we want is we want New York 311. So here we have Marketplace, New York City 311, and then View Dataset. Takes a moment. What we want to do first is we want to look at the data and essentially this data dictionary that they have here. So open the table. All right, so we want to figure out what relevant information we want. We said we want longitude and latitude. We want borough. We can see here the different types. Notice that this isn't filled out, so we don't have descriptions. We can preview the data so we can see what it's looking like. If we're thinking we want to categorize, for example, how many of a certain type of incident occur, then we need to look at the data and say, okay, well, the boroughs, you can see there's general naming schemes there. And we're looking at different types of incidents. So we might do an initial query here to check in our new split tab. Let's turn this back to schema so I can see this. So we want to select and let's do complaint type. And here we want to do distinct just because we want to make sure that whatever we're picking is distinct. And we want to make sure we have the right naming scheme. So when we do this, select distinct complaint type, then what we can see is that we have mold, safety, plumbing, illegal parking. Notice that the first letters are capitalized. And so if we're looking for Maybe I want to order it. Order by complaint type. Okay. And I'll run that. All right, a bunch of gobbledygook here. So you can see some of these are write-in, which have just a mess. So we don't want that. But we could look at these and say, okay, dead animal. So where are the dead animals? So we could pull information by dead animal. In this particular example, I'm having you pull by poison ivy. So if we just look here, poison ivy, you can see how it is framed. The P is capitalized, the I is capitalized, which means when we do our query, we need to make sure we match that. Okay, so to do this, we're going to select unique ID, borough, incident zip, longitude, and latitude from our BigQuery New York 311, where complaint type equals poison ivy. In a moment on your own, try doing a different one. Try the dead animal one. See if you can pull the data for the locations of the dead animals. And we're going to take the poison ivy, we're going to graph it so we can see where they are, but also try the dead animal one and see what you come up with. All right, so let's take this query. Let's go in. So we're going to select distinct, and we don't want just complaint type. We want perhaps unique key, borough, incident zip, longitude, latitude, and we're going to do from BigQuery service requests where complaint type equals poison ivy. Okay. We don't actually need the complaint type in here because they're all going to be poison ivy, so you could probably leave that out. Since this database is just going to be poison ivy, or if you change this out to dead animal, it's going to be just dead animal. All right, so this query will run. Let's run it. All right, we get a data set. Now let's go, and this is the part my face is covering up, but let's take this one and let's go explore data and see, open it in Python. So we can have it show us the SQL code if you want. Same thing you typed in. We can have it pull in the database. So here's the data set that's created. So notice it's just longitude, latitude, zip code, borough, and then a unique key for the poison ivy. So it's not the entire data set, it's just the subset we pulled. We could say show descriptive statistics, but again, this data set doesn't really have any meaning because, I mean, you could find a central location because you've averaged the latitude and you've averaged the longitude, but that's not super helpful. So let's try something else that could be helpful. So let's actually create a graph that shows where the poison ivy is happening. So we need to import numpy as np. We need to import matplotlib.pyplot as plt. And what we're going to do is we're going to have it take that results table and do the value counts. So it's going to take the different numerical responses, the nominal data, the categories for the boroughs, so Manhattan, the Bronx, and it's going to count how many events, how many poison ivies happened in that location. So that's what this results.value counts, parentheses, borough, says it's going to count the number of rows that have a particular type of borough. And then we can plot it. And so we can plot with what is a vertical bar graph. On the x-axis, we will put borough as the label. Y-axis, that's the vertical, is going to be the counts. Because these are words for our labels, we probably want to rotate the words about 45 degrees just to make it easier to read. And then, of course, show our graph. So let's actually take this and let's go into this data set it just gave us. That's the tree one. So let's go to the right one. So we have this table called results. And the first thing we need to do is import our relevant packages, one for graphing, one for manipulation. Then what we're going to do is we're going to have it take our table, not the summary table, but take our original table that's up here called results, and we are going to have it count the number of rows that fall under each borough. So results, that's the name of the table, dot value counts, that's the command, and then we're applying it by borough. So make sure that matches the name of the variable in the table. And results is the name of the table itself, and then we'll call this output Ivy. Okay, if you want to see what Ivy looks like, you can just do Ivy here, and so you can see the counts by borough. Well, let's actually plot that information. So we're going to plot this new information we're calling Ivy. The kind is a bar graph. The x-axis is borough. The y-axis, that's the vertical, is the count. And as we said, we're going to rotate the labels by 45. Let's run that. And so here we can see that Staten Island has the most amount of poison ivy, followed by Queens, then Brooklyn, Bronx, with Manhattan the least. Which makes sense. There's not as much green space in Manhattan. If it is, it's a park that is highly kind of structured and maintained because there's a lot of concrete around it. So poison ivy is not as big of a deal as in terms of more rural areas like Staten Island. So we can then take this information and we can take it and we can then analyze it, do data visualizations from it. And if you instead had chosen to, instead of having it go directly to Python, if instead you had chosen to output it as a CSV file, we can do that same analysis. So export job has started. We're just waiting for it. Say go to drive. Remember, I need to rename it and I need to choose a new location for it. So I'm just going to move my face. All right, so here I am, and I'm going to rename it, and this is going to be Poison Ivy. Okay, and then I am going to move it, and let's say I'll put it here in my slides. Move to here. Okay, so now that I've done that, what I would do is I would go in. Here's my slides. Here's my poison ivy that I just added. Oh, disappeared. Where'd it go? Poison ivy. Okay, so then what you can do is you can go new. Don't want a new folder. Come on. I'm a little sluggish here. New and more. And we're doing Google Collab. So I want to load in my data set. To load in your data set, I'll just show you a slide here. You're going to need a couple sets of commands. So first one is going to be from Google.Collab, import drive and mount the drive. So this is telling your Google Drive that it can be used. There we go. So this says, okay, it's going to go to Google Drive, my Google Drive, to get the data set. So when you run this in Python, it will request to connect to your Google Drive. So this is just you. You'll notice that in my Python workbooks, I have the same information. You're not connecting to my workbooks, you're connecting to your own. So I'm giving it access to my Google Drive. And then the other piece is you're going to have to tell it where to go find it. So it's now connected. So I would just keep this kind of command handy, results equals. Okay, we are going to be using pandas as PD. So it needs that first, and you know it needs that because this says PD. So we'll import pandas as PD. And then we're going to read the CSV file, and then it needs to know where it is. So the start here is going to be content/drive/my drive. And then from there, it's simply going to be the folders in your Google Drive. So my slides folder is in my BA handbook /slides/ and then it's not called results. We called it poison ivy. So you got to make sure this matches. The My Drive part stays the same, and then it's the folder and the folder inside that, and however many levels you go. Try not to do too many levels. It gets kind of complainy. And then the name of your file. So we run that. And then to make sure it worked, I can do things like results.head, and that's going to show me the first 5 rows of my table. And so then what I can do is I can use that same command we had used previously for our graphing. So first I need my packages, code, import those because they're not already running in this Python. Then I'm going to need to have it count up how many for each borough. And of course, you can put this all into one. It doesn't have to be in separate. I like to put them separate just so I can then check them. But you can see I can get that same graph in my Python workbook, which I should name and save, without having to have Biq Query create that one for me. So if you want to control a bit more and have that file of your database exported and saved, then you can use your, figure out where it is, got to go to the right one. Then you can use the save results.csv, which of course my face is covering. Save results.csv to allow you to store it, and then you can call it later as you want. Otherwise, if you have it create the Python workbook for you, you need to save that workbook. You can also export the spreadsheet from that Python code. Is another option, but it's extra steps. So now we know how to pull data out of a cloud computing based database like Google Cloud. And so now we can start to analyze it, create more data visualizations, do some descriptive and inferential statistics, and then start doing more complicated types of analysis.